All right. So, hello, my name is Ejika Peter Ojonugwa Oluwafemi. Um, I'm a graduate assistant on the PCP project. So today I'll be showing you the experiment for COSC 241, which is our computer systems and logic. So um, before we start, I would like to show you some of the equipment we are going to be using for the experiment. So for this experiment, we are going to be demonstrating some of the logic gates and how they work. So to do this, we need some equipment. The first equipment we are going to be using here is the breadboard. So this is the breadboard. The breadboard is labeled positive and negative on both sides, and if you look closer, it has alphabets A, B, C, D, E, F down to J. So this is how we'll do tracing, and it's vertically it's numbered from 5 to 60. So whenever I'm placing the other equipments on the board, we are going to be using these alphabets and numbers for tracing. So the next equipment we are going to be using is the battery. So this is a battery. We'll be using it to power the breadboard, but we are going to be powering the breadboard via the PCB board I'll be introducing to you much later. The next is the PCB board. So this is a board that was designed recently. It's going to make the work more easier to navigate. The board consists of 4 switches. These 4 switches signify switches for input. So we have it's labeled B1 and B0 and A1 and A0. They are both inputs. They are all signifying inputs. And on the board, on the other side of the board here, you have LED. These LEDs are labeled from S0 down to S3. They signify the output of the system. If you come closer, you see we have 6 pins here. We have 1, 2, 3, 4, 5. We have 5 pins on this side, and we have 5 pins here. These pins goes into the breadboard, and these pins are carefully labeled S1, S2, S3, and S0 as signified here on the board: S0, S1, S2, and S3. And on the other end, we have the input pins, which are A1, A0, B1, B0, and we have the VCC, which is 5 volts. So when you look closer, you'll be able to see it. During the practical, you will have your own boards to yourself. So the next equipment we are going to be using here is the IC. The IC, otherwise known as the integrated circuit. So we are going to be using several ICs to represent the gates in the experiment. We have the OR gates, we have the AND gates, we have the NAND gates, the exclusive OR gates, and of course we have the NAND gates. So for this experiment also, we are going to be using different types of jumper wires. We have the longer ones. You can see they are of different colors and different types. We have the shorter ones. So I'll be showing you how to connect everything during the course of this experiment. So before I start properly, when you have something like this, you want to confirm if it works or if it does not work. So the first thing you want to do is to bring the PCB board to the positive part of the board. So you place it around J60, that is column J, row 60. You want to place it around here and fix it carefully. Okay, so you can see it's fixed. I've connected the PCB boards to the breadboard, and it's all fixed on column J, row 60 to 55. So the next thing you want to do is to connect the battery to the board. So look at the battery, you can see the edges. So the other side here goes to this part, and the smaller side goes to this part. So you connect carefully. Okay, so to confirm if the PCB board and the breadboard is working, so you turn on the controls. You can see, okay, it means B0's input is working, as well as the S1. You want to trigger all the boards. So as you can see, everything works fine. So it means the board is working, the PCB board is working, the battery is working, and our breadboard is working. So from now we can go straight into the experiment proper. Okay, let me disconnect this, turn off the board, and remove carefully. Okay, now take a look at this breadboard. The first thing I want to do is to connect my IC. So this IC comprises of 14 pins. So of the 14 pins, we have the input pins and the output pins on both sides. So this IC I'm holding currently is the AND gate. If you look closer, this is the architecture of how the AND gates look like internally. You see a cup-like shape, a notch at the edge, that's signifying the area where the VCC is. So comparing this, the VCC has pin number 14, and at the other edge, which is this pin here, that's the last pin here, this is where the notch is. This is number 14 and this is number 7. So the pin is counted from the left part of the VCC as pin 1, 2, 3, 4, 5, 6, 7. 7 is the ground, 14 is the VCC. So pin 1 and 2 are input pins and pin 3 output pin. In this whole circuit contains 3 OR gates, so you can implement OR gates from 3 different directions depending on what you want to use. So pin 1 and 2 are input pins, while pin 3 is an output pin. Pin 4 and 5 input pin, while pin 6 is an output pin. Pin 7 is the ground. So to connect this properly, you want to make sure that the notch is facing the direction of the board. Look at the cup-shaped notch here. You want to make sure it's facing the direction of the board. So I'll plug in the notch I'll place it between the 2 parts of the board. So this will be connected. It means anything I'm doing is going to be working on both sides of the board. Remember when we tested initially, we tested from this side of the board. So I'm connecting to F35 and D35. So the frontal pins here goes into F35 on the board and E35, and the last pin should be immediately after F30 and E30 and D30, sorry. So you go on and you carefully insert the IC into the board. Okay. Once this is complete, you want to check that it's well placed, and there you go. So the next thing you want to do is to connect your PCB board to the breadboard. So how do you do that? Remember how we connected initially, so we'll follow that same step. So you bring it down to, you make sure your pin is sitting between F60 and E60. So you do that and you push it down gradually. Good. So it's all fitted in now. So if you look closer, this is our, let me use this jumper wire to show you gradually. This is 5 volts. This 5 volts stands for the VCC. It represents the area where you connect the VCC. And you see GNLD. GND means ground. That is where you connect the ground. Also, if you come back to the IC and you look at our architectural diagram here, you see that this is pin 14 and this is pin 7. This is pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7. So this is pin 8, pin 9, pin 10, 11, 12, 13, and 14. So this is our VCC and this is our ground. So first of all, what we want to do is to connect our VCC. So to connect our VCC, I'm going to insert a jumper wire here, in line here, straight line with the with the 5 volt labeled area. So I'll insert a jumper wire here and I'll connect it to the positive part of the board. Look at the board is labeled plus and minus, that is positive and negative. So the VCC goes to the positive part of the board. Okay, so it's all connected now. You can see it goes from the 5 volts here to the positive part of the board. So the next thing you want to do is to connect the VCC on the IC. So we'll come here to pin 14. Where's pin R? Pin 14. Then we connect it to the positive part of the board also. So this means that we have connected the 2 VCCs on the system. So from here, I'll go on and connect the ground. So you insert a jumper wire in the same line. This is line 60 here, so I'll put a jumper wire here and I'll connect it to, okay, let me use another color for clarity. I'll pick a green. So I'll insert a jumper wire here and I'll connect it to the negative part of the board. You fold it carefully. Let me bring it close here so that you can see very well. Make sure it goes into the negative part of the board. Can you see it? Okay, so the next thing is to connect the second ground, which is here. This is your pin 7. So I'll put it here and watch closely. So yeah, let me make it straight. Okay, so we have connected the negative, the ground here to the negative. We have connected the ground on the IC to the negative. We've connected our VCC here to the positive part of the board, and we've connected our 5 volts here to the positive part of the board. So looking at this architectural diagram on my screen here, what I want to do next is to connect the input. So I want to use pin 1 and 2 as my input, and I would like to use pin 3 as my output. So to do this, I'll take a jumper wire from B0, which is here. I'll take a jumper wire from B0, which is here. If you trace it to this, that's a line below 55. I'll take it down to this point. That's pin 1. Then to connect my second input, I'll take it down from B1 down to the second part here. And finally, to get my output, I would need to connect from, I want to use XNOR as my output here. That is this XNOR here. Look at XNOR. I want XNOR. That is this. I want this LED here to display if it's correct or not, if it's active or not. So I'm going to take a jumper wire from XNOR down to pin 3. I want pin 3 to be my output. So overall, you can see how the board looks like, right? So you can see the connection for the VCC, the connection for the ground, You can see the connection for the VCC. You can see connection for the ground. So the next process here is to connect our battery. So we are connecting to power source. Okay. We are going to be validating the result of this experiment based on the outputs we get from this experiment. So how do we validate this? We validate the result of this experiment from a concept that you might have been introduced to in class. It's called a truth table. So a truth table contains the inputs and output and the results. So an example of a truth table is what you see on my screen right now. So this is the input and this is the output. You have two inputs and you have one output. So this is the experiment for an OR gate, the truth table for an OR gate. So the first input here is 0 and the second input here is 0. So let's see if we have 0. So currently the board is at a state of 0, B1 is 0, B0 is 0. So you can see the output is nothing. There is no trigger here. Okay, so the next is when you have B1 to be 0 and B0 to be 1. So we have B0 here as 0. So let's turn on B1. Let's change the state from state 0 to state 1. So when I flip the switch, you can see there's an action here. That is, the LED is on for S0. So I'll turn it back and restore it back to 0. So we try it when B1 is 1 and B0 is 1. So I'll turn on B1, B0 and turn on B1. So you can see we've changed the switch. They are both having 1 and 1 and you can see it's on. So when you turn it back off, that is not and not, you have what? 0. So to validate this experiment for OR gates, you have 0 0 will give you 0 0 1. So on this we use the switch here. The switch can be in either two states, 1 or 0. So when you turn on the switch, it's on 1. When you turn on this, is on 1. When you turn it off, it's 0. So you can see it's at the state of 0. So this is the experiments for an OR gate. So in the class experiments, you'll be given different ICs and different gates to experiment on with. If you have any questions, you can drop it in the comment section, or you can reach out to me during the class experiment or via my mail, and I'll respond to you accordingly. Thank you very much.